you cannot do. You want to add two strings, creative function only. Okay. Now coming to the next topic, we have a storage classes. It is a simple topic. Okay. Generally what happens is whenever you have a memory provided, so in any operating system you will get certain bytes of memory. Okay. Now in any system the whole memory is divided into two sections, especially in the Linux based operating systems. Okay, but it happens in your Windows also, do not worry. Any memory which is available in your computer, I'm speaking about the RAM memory. Okay, random access memory. So the memory gets splitted into two sections. One is the user space, the other one is the kernel space. So user space is where we being the programmers can access the memory. Kernel space is where your operating system is accessing the memory. Okay, we have two spaces, user space and kernel space. User space is where we normal users will get the memory allocated. Kernel space is where operating system is getting its memory allocated. We being the normal users cannot access the kernel space. It is a restricted memory. Okay, anytime you try accessing the kernel space, you get segmentation fault. Now, this memory will have n number of processes running. If you look at my system, I have many processes running right now. I have a Microsoft Edge running. I have a journal running. I have VS Code running. I have GoToMeeting running. I also have a Chrome running. So I have n number of processes running at a time. Now these processes are considered as P1, P2, P3, P4 and so on. Each of these processes will get certain bytes of memory allocated. Okay, all of these processes will get certain bytes of memory allocated. One of that process is your program. Okay, your C program is one of the process which is running. So here what happens is when your process gets certain bytes of memory allocated, that memory is divided into 4 segments. One is the text segment, then we have stack segment, we have data segment and the heap segment. So at the bottom you see is the text segment, above that you see is the data segment, then we have the heap segment, we have the stack segment. Okay, so let's say your process is your VS Code, or let's say your process is your online compiler. Once your process is running, you get certain bytes of memory allocated. And that memory is splitted into 4 segments. Text segment, stack segment, data segment, heap segment. Now who sits in each of these segments is a question. In the text segment, your program is placed. Whatever program you are going to write is placed in the text segment. And that should not be modified. Hence, text segment is also called as read-only segment. Okay. So, text segment is only called as read-only segment. You cannot modify your program once it is written. Okay. While the program is being executed, you cannot modify your program. Hence, your program is written in a separate memory called as text segment. Then above that you have is data segment. Data segment is further divided into 2 sections, initialized and uninitialized data segment. I hope you remember yesterday we studied about static. Any variable, along with the variable we declare static whenever you want to return a variable from one function to another. That static variable sits in the data segment. So it sits in initialized data segment if it is given with a value. It sits in uninitialized data segment if it is not initialized. Okay, so that is your data segment. Above that we have is heap segment where dynamic memory allocation happens. You don't have to worry about dynamic memory allocation. It is like the memory which will be handled by the user. Okay, we being the user, if we want to handle the memory, then it is in the heap segment. And one last is stack segment where all of your variables are placed. Okay, your variables are placed in the stack segment. Now, here are some of the things. Okay, let me explain you about a auto-local variable. Okay, I am explaining about auto-local variable. For example, inside the main function, I declare one variable, okay, int num. This is an example of auto-local variable. The num can be accessed only inside the main function. It is local to that main function. We call it as auto-local variable. Now, we have a register local variable. Any variable declared with register keyword, we call it as register local variable. Why do we have to declare it as register is when you want to access this variable more often. So whenever you have to access the variable more often, then we make it as register. The reason behind that is memory for a register variable will be present close to the CPU. Okay, memory for any register local variable will be given close to the CPU. So because it is close to the CPU can access it easily and with less amount of time. So whenever a variable is to be accessed more often, it is made as register. Okay. Then we have a static local variable. So static local variable is when you want that variable to stay even after you step out of the function. Okay. So you want to make that variable stay even after stepping out of the function. You're going to take it as static. Okay. Let me specify here register when variable is accessed more often. Okay. So when you want to access this variable more often, it is register. Similarly, in case of static, it is when you want the variable to stay even after stepping out of the function. Okay, when variable is to be with user even after coming out of the function. So even after coming out of the function, you want that variable to stay with the user, then you have to make it as static local. Now coming to global variable. So global variable means it's a variable which is declared outside a function. Okay. So let's say I have the main function here. So I have the main function here, and outside the main function, I'm going to have one variable declared. This is global variable. The reason why we take a global variable is we have to use this anywhere throughout the program. Okay, to use the num anywhere in the program. Okay, you want to use it anywhere in the program, then it is a global variable. In fact, you can use it in other files also. Even in other files. You want to use it in other files also, then you can go for a global variable. Now, static global variable means it's a variable you want to use anywhere but not in other files. Okay, you write static here. Okay, to use the num anywhere in the program, even anywhere in the program but in the same file. So you want to use that variable only in that file, then you have to make use of static. Okay, so these are the variables. So in case of global variable, you are going to use that variable anywhere. Inside main function you want, you can use. You write another function, you can use it in that function also. So that is global variable. You take another file, you want to use it in another file also, global variable can be used. But static global variable should be used only inside that file. You cannot use it in other file. Okay, using it in other file is not possible. So that is global variable. So that is what we have here in the example. Okay. So, and when you want to use a global variable from one file to another, we make use of extern keyword. This is a global variable. I want to use it in another file. So I should make use of extern keyword. Okay. Let's say I'll write it here. This is one global variable file. This is another file. Let's say you want to develop a project. You don't do it in one file. You are going to do it in multiple files. So this is our 1.c file and this is our 2.c file. Okay. Now I write my main function here. One global variable I'll have and I'll write my main function here. The other function, let's say I write it in another file. So let's say I'm writing a display function here in a separate file. I don't want to write everything in the same file. If this variable should be brought to this file, then it is brought with the help of extern keyword. This global variable to be brought to this file. You want to use this num not only in this file, in the other file also. It is brought using extern in num like this. Okay, that is global variable. Now, if it is static global variable, then using it in another file gives you error. Okay, so let's say this is static. Okay, if you write it like this, then here using extern is not possible. You cannot. It has to be used only in this file. Taking it to the other file is impossible. Okay, so taking it to the other file is not possible like this. So you cannot use this in another file. Okay, so that is how global variables are taken. There is a global variable you want to access in another file, then you do it with the help of extern keyword. There is a static global variable you want to use it in another file, not possible. So that is going to give me an error. Bhavya, I'm saying static and global are two different things. Global is one thing, static global is another thing. Okay, so in static you have static global, you have static local also. If it is static local, you put it inside a function. If it is static global, you put it outside the function. Okay. So these are the types of variables you can declare. So please note this down and we'll take a break of 2 minutes. We'll start with last chapter. Okay, so this is about the storage classes. So the next we have got is to start with preprocessor. Okay, next chapter is preprocessor. So whatever we have been writing as include so far, that is a part of preprocessor. Okay, so as include stdio.h, as include string.h. So they all are preprocessor directives. Okay, as include will say please include this stdio.h file. Okay, that we call it as include. Now it is a kind of including the header file. Okay, as include is to include a header file, and we have two reasons to include a header file. So one reason to include a built-in header file is to make use of your hardwares. For example, you want to print something, you want to read something, you want your keyboard, you want your monitor, that is asked by including the built-in header file stdio.h. So for that reason we use built-in header file. Then we write our own header file. When we want to write the functions prototype and I want to share it among other people, then that is to include a user defined header file. So the difference between a header file and a source file is your .c file is where your programs are written. So it will have the functions you are going to write. It will have some variables you declare. It will have some macros you write which cannot be shared. Whereas anything you put inside the header file can be shared. So what will you have inside a header file is you will have functions prototype. So this whatever we wrote yesterday, this first line is called as functions prototype. Okay. So anytime you wrote the functions prototype, that is written, this is functions prototype. So that is written inside your header file which can be shared among other files also. Okay, so that is header file. It will have some macros. It will have some data types which can be shared among the people. Now two ways of including a header file. I think we have always been using this. This is to include a user defined header file. Sorry, built-in header file. So stdio.h, string.h, they all are the header files returned by the system, by the compiler. They are built-in header files. You did not write it. So to include such header files, you use angular parenthesis. This we call it as angular parenthesis. So whenever you include a header file like this, it searches for the header file in your system main path. So there is one dedicated path where built-in header files are stored. Whenever you include a header file using angular parenthesis, your computer will search for that header file in the standard path. If a header file is included using double quotes, then that is to include a user-defined header file. Okay, so we being the users should include a user-defined header file. So to include a user-defined header file, we use double quotes. Now, why do we have to use double quotes? I want that header file to be searched in that specific path. Okay, I don't want that to be searched somewhere. I want it to be searched only in the place where I have stored it. So to include a user-defined header file, if I create my own header file, then it should be included using double quotes. Okay, and any header file should be included for only once. Okay, hereafter, whenever you create your own header file, okay, I will teach you how to create a header file. So in the header file, you will have some functions prototype written. This is my header file. Let's say head.h. Okay. Now what will you write inside this is, you will write all functions prototype. Let's say you are writing a sum function. Sum functions prototype, you will write it here. Okay. Let's say you write a display function. That display functions prototype, you are going to write it here. Int star ptr, something like this. Any function you write, its prototype is written here. Now when you are writing a header file, please have a habit of writing it like this. First line, hash if not defined of name, hash define name, and at the end hash endif. So why do you have to write it like this is, whatever you write in the header file should be written in your program for only once. By mistake, if you include a header file for twice, it should not cause you any error. That is common. Okay. Especially when you are doing big projects, including a same header file for more than once is common. Okay. Even by mistake you include a header file for more than once, you have to make sure that your computer is including it for only once. Okay. You cannot let it get included for more than once. You have to make sure that it is being included for only once. And that is done with the hash if not def, hash define, hash endif. So when you write these lines before the contents of your header file, then you will make sure when you include this head.h in your files using double quotes, even if you include it for more than once, the contents will be included for only once. So that is head.h. That is how you are going to write your own header files hereafter. Now what is this hash define is? We call it as macro. Hash define is a macro. Hash define, let's say pi 3.142. So hash define is a way of defining a constant. Giving a name for a giving a name for a constant, we call it as a macro. Okay, it is done using hash define. So object like macro is a simple identifier which will be replaced by a code fragment. See, hash define buffer size 1024. So wherever 1020 buffer size is seen in your program, it will be replaced by 1024. Okay. So hash define is the process of defining a macro. You give a name, give a value for it to represent. So for example, hash define buffer size 1024. Wherever buffer size is seen, it will be replaced with 1024. Similarly, wherever pi is seen, it will be replaced with 3.142. So that is macro. Okay. So macro is giving a name for a symbolic constant. If endif stands for if not defined, endif is to end the if condition. This is to make sure that the contents of header file is been added for only once in your program, even after you include it for multiple times. Okay. So that is your macro. So we have one more macro here. Okay. This is one more macro. We call it as function like macro. Hash define set bits num comma position. I am writing a macro called set bit. The macro is going to take two inputs, num, position. So after taking two inputs, what should it perform is specified here. I wanted to perform num or with one left shifted for position times. So actually wherever this macro is found, it gets replaced with the value it is representing. Means once this macro is returned, it is replaced with num is receiving 0, position is receiving 2. So this line will be replaced with 0 or with 1 left shifted for 2 times. Like this it will be replaced. Okay. So this kind of replacement happens when a macro is called. So macro means it is a text substitution. You write a constant or you write a value it is going to represent. Okay. So that is a macro. And this is a multi-line macro. When you want to write a macro using multiple lines, you are going to add a backslash at the end of each line. Please remember there should be nothing available at the end after this. So if you are not comfortable writing a macro in a single line, you can split it in multiple lines. In order to split it in multiple lines, every line should be terminated with a backslash. Okay, so that is about the macro. And these are some of the built-in macros. You see, double underscore file double underscore is a built-in macro. It will be replaced with the file name you are working. Double underscore date double underscore is a macro. It will be replaced with today's date. Double underscore time double underscore is a macro. It gets replaced with today's time. Double underscore func double underscore is a macro. It gets replaced with the function you are working. And double underscore line double underscore gets replaced with the line number in which you are working. Okay. Harish is asking, without writing macro, we can use the functions. Yes, you can. You want to write macros, you can write. You want to write functions, you can write. Okay. These are some of the built-in macros. File, date, time, func, and line are the 5 built-in macros. So this completes the C module. And we now have to start with microcontrollers module. So, but the microcontrollers module will be starting from tomorrow. Okay. Starting from tomorrow, you're going to have the microcontrollers module started, wherein you will study how to implement a simple embedded system. You will study about some of the peripherals. You will be given with a project. That project will be done with the help of the C programming language. Okay. Using the C programming language, the things will be done for programming. You will study about some of the peripherals, how to configure some of the peripherals and how to do the project. Okay. So this PPT is already there in your LMS, and this notes, what you see, will also be provided to you, which you can access anytime. Okay. So it will be there in your LMS only. You can access it anytime. So that is about the contents. Macro, I'm just briefing out. Whenever you write a macro, you write it using #define. So you want a name to be given for a constant value. You do it using #define. You give a name and this is the constant value it has to represent. Similarly, you give a name for the operation you want to perform. That is also done using #define. The name you are giving is setBit and it has to take 2 inputs, num, position. So whenever this setBit macro is used, it gets replaced with the value it is representing. Okay. So that will be your macros. You can start working on assignments. You can keep it ready. From tomorrow, you will start with your microcontrollers module. The project will be started. And this is your LMS. So in your LMS, under internship, you're going to find all of your class recordings. Okay, so here under the class recordings you can see all of them. Today's class I will be adding here after the class gets completed. Also I will add this document which you can refer anytime. Okay, so that is it. You want to study anything in brief, I mean in detail? C is not something which can be learnt in 10 or 15 days. In fact, we take it for 3 months. The C module will be taught for 3 months in our course. So you are interested, you can join, okay, wherein you will study the C module in detail. So it will be for a duration of 3 months. Just C will take 3 months. Okay, so that is something you will have to figure out. Anyway, starting from tomorrow, microcontrollers module will be started. Thank you all. It was great teaching you all with respect to the C module. You can leave the session now, and your next session starts from tomorrow with respect to the microcontrollers module. Thank you all and have a good time.